Hey everyone, this is Vito and with me is Shian. We are both senior cloud solution architects here at Microsoft APAC. Today, we are going to talk about the importance of securing the software development lifecycle and the difference of building on secure infrastructure and the advantages that comes along with it. Right, let's start with an urgent call. Folks, enterprise can no longer wait to address security. It only takes 3 days for a hacker to exploit a vulnerability, leaving security teams little room for errors in their response. Attackers now shift left and compromise upstream dependencies and engineering systems. The result is that these attacks can impact entire development environment and software supply chains. With this threat landscape that is changing, we have already seen two examples of modern attack vectors, Codecov and Electronic Arts. In Codecov's case, an attacker targeted their developer workflow and software supply chain. The attacker was not only able to gain access to their Google Cloud storage account, but also to upload a new image into thousands of builds that scan their software supply chain, extracting even more secrets and widening the breach. Another example is EA. EA recently had source code from one of their games stolen due to stolen cookies that contain Slack login information. They didn't have the secret or identity protections needed, and these vulnerabilities became an easy target. There's also a recent supply chain security example known as the Log4j vulnerability. This has impacted more than 35,000 Java artifacts. The vulnerability, which comes from a popular logging tool in the biggest Java library, the Maven Central Repository, allows an attacker to perform remote code execution by exploiting the insecure JNDI lookups exposed by the logging library Log4j. This exploitable feature was enabled by default in many versions of the library, and this allowed the attack to spread to many affected parties all at once. Well, this is not just an issue for enterprises. The US government has also taken notice of the new threat vectors targeting federal networks and data centers. The Biden administration recently signed an executive order to place more stringent requirements on public sector entities to ensure the US is more prepared for the next age of cybersecurity. Just like GDPR, these guidelines from the President's Office dictate rules for vendors securing and implementing their software throughout the nation. To safeguard the developer cloud against these new threat types, the answer is to shift security left and leverage cloud-native security. Shifting left helps enterprises find and remediate vulnerabilities earlier and across their development lifecycle. Enterprises that extend security to development reduce security incidents by 80%. And it's not just a reduction in events, there is also a financial component. It costs 60 times more to fix a security defect in production than in development. Blending security and development together within the development workflow remains a challenge for many enterprises. While more enterprises are starting their transforms, there are 62% of enterprises that have yet to integrate security into the development phase. Now, how do we start shifting security left and moving to cloud-native environments? First, it's important to understand the differences between adopting DevOps and DevSecOps. You may be familiar with how DevOps practices and collaboration between developer and operations teams led to faster delivery. DevOps combines. In the sprint towards digital transformation, DevOps had been adopted at a much higher rate than DevSecOps. And here's why. DevOps directly impacts a developer's ability to deliver, which, as a result, impacts an organization's ability to deliver value to customers. And organizations are quick to evolve in a way that allows them to code, collaborate, and ship faster and more efficiently to deliver continuous value to their users. DevOps also provides developers with a lot of positives. Developers are saving time and shipping more code faster. The code is of a much higher caliber, and it leads to continuous workflow improvements and work satisfaction. However, organizations that adopt DevSecOps unlock the ability to ship code at the same speed securely. Specifically, DevSecOps help organizations shift security left to occur at more critical points throughout the development lifecycle. It also helps organizations to form a seamless workflow by integrating into existing tool chains. More so, this aids organizations to continually identify new threat vectors. DevSecOps presents barriers and inefficiencies for developers that we don't find with DevOps. These include organization and team gaps. Some organizations have security-specific teams who own all of security. This silos DevOps and SecOps and leads to fragmented security culture. Secondly, skill and knowledge gaps. When DevOps and Dev teams don't see security as part of their responsibility, the skill base solely stays within the SecOps team. Third, solutions are not being built for developers, leading to issues like false positives. False positives are high because the tools live with security teams rather than developers. Since security teams are more likely to scan repos than developers, they may only run them once a quarter, causing them to be higher than the rate would be if this tool lives with developers. Another issue is that we also see misaligned expectations. In DevOps, having a 30% failure rate on unit tests is considered very bad. However, in security, having a 30% failure rate is actually good. While we are always dealing with a trade-off between false positives and false negatives, security prefers no false negatives and more false positives. However, a developer doesn't want any false positive and doesn't care as much about false negatives. Even with these benefits, DevSecOps adoption is slower, and part of that is due to required organizational changes. It's also due to knowledge gaps that must be filled in order to safeguard the developer cloud. There are different key criteria for success for developers and CISOs. Development teams are all about speed and productivity. Generally, their teams have three main requirements. The first is to ensure developer velocity is maximized, so there are no limits to innovation and speed. The second is to not put any increased complexity on the developer. How? Through developer-first tooling that's secure by design. And third, to involve developers in security conversation and empower them to contribute. And for CISOs, it's more about protecting company IP, data, and secrets without impeding the development process. Their top 3 requirements reflect this difference. The first is to augment security practices with cutting-edge forensic and detection tools. Another is visibility across applications from testing to production. And this requires partnering with developer teams to gain holistic observability. And last, it is the ability to proactively hunt threats instead of operating in a state of reactive security. Fortunately, DevSecOps finds commonalities for both developers and CISOs at an organizational level. First, we find shared accountability through adopting security as a company-wide culture and tracking the right metrics. We also find it from securing the development environment to limit developer machines, infrastructure, and code bases as attack vectors. And lastly, it's about seamlessly integrating security in the developer workflow to involve developers in security processes in a non-intrusive way. First, let's talk about shared accountability. To make DevSecOps successful, it's crucial to break down silos between DevOps and SecOps and provide alignment between their KPIs. As we think about shifting from centralized security teams to including developers as accountable, we need to shift from having a centralized security team to a culture of security as a shared responsibility. Let's start by aligning on the metrics to measure. It's important to focus on measuring only the most critical and impactful KPIs. Historically, developers have tracked deployment and shipping speeds associated with pipeline throughput. Now, along with pipeline throughput, it's important to focus on metrics that deal with life site health. Generally, the most critical metrics to track are time to detect, time to communicate, and time to mitigate. Focusing on these 3 metrics allow your organization to lower the time to respond to vulnerabilities within that crucial 3-day window. Next, let's discuss securing the development environment. Securing the development environment begins with securing all cloud-based developer machines. That means we need to place strict controls on how developers interact with their environments. For code browsing, we should limit scope for non-trusted repositories to a browser sandbox. We also should only build non-trusted repositories in an isolated environment, not on a local developer machine. And identity policy management is important too. Clone repositories should implement least privilege access principles. When implemented correctly, you are defending your organization against common attacks. Let's have a look at Codespaces. This is the sample app that I forked from Azure samples that I will use for this session. The reason we fork the code is to make changes further down the road. With that, we can now start our code spaces. So we'll create a code space based on the main branch of this repository. And you'll take a little bit of time, not too long. Okay, it indicates that the image had been found and the container to run the development environment had been built. Okay, now that's the code spaces started. Remember earlier I mentioned that we will need to modify the code more. So here I'm noticing that there is no dev container definition. So dev container.json allows us to be more precise with the kind of development environment that we want. So here I'm noticing that we do not have Docker extension or Azure Container Apps extension installed. So let's go about getting that into our dev container. So we start by looking for Docker. So instead of installing it like this, what we want to do is right click and add it to our dev container. So by having this dev container, it will not just benefit us, it will benefit other developers as well, as they will definitely need to have these kind of extensions working at their code space as well. So here there's no container configuration currently found, so I'll add one, and let's add one that's based on Node.js. Let's look for the default one, and we'll need Docker as well. So let's go for Docker from Docker. Let's reuse the host Docker engine, and we'll look for, go for the latest one, and there we go. We have a dev container.json now. Let's look here. Right, cool. Within the dev container.json definition, we will now see that the Docker extension had been added to the list of extensions. These are the extensions that will be automatically added when we turn on our code space the next time. And we have Docker from Docker as a feature as well. Now let's commit our code and see how it can benefit the next developer. So let's add to Git and commit and push. Okay, so let's have a look at how the next developer can then see this extension already added when they turn on a new code spaces based on this repository. Let's go to the repo over here. Okay, so let's turn on a new code space. So notice that there's already two code space. So I'm going to create a new one. So again, it's going to build the container again. Okay, let's view logs just to see. See, notice it takes a little bit longer. It's setting up the necessary Docker, and okay, now it's done. Yeah, container started. Okay, now it's saying that Docker from Docker is not a V2 feature. Okay. Okay, so now this is a new Codespaces, but it's actually turned on based on our newer code with dev container added. So this is the dev container file, right? So let's see if we have our magic here, which is the Docker extension installed. Yay! So yeah, so the next developer, imagine, will then save a step by having this extension already there. Remember seeing the notification on Docker from Docker earlier while turning on the Codespace? Right, let's find out what's that about. We can do that with the creation log, and we can access it from the command palette. Let's go to creation log. Yeah, so this is the creation log, and let's head to Docker from Docker. Yeah, so let's get a detailed view. So feature Docker from Docker is not a V2 feature, attempting fallback to V1. Yeah, that's fine for our purposes. Okay, now the next thing we should do is to build our application. Let's look for our Docker file, which is the source Docker file, which is this one. Okay, then we build a image in our dev environment here. So yeah, that is fine. Probably a little bit of a wait here. Let's load this up. Okay, that's fast enough. Now we can turn on our containers. Let's bring up the Docker extension. Yep, and this is the image. Let's run. And we have our container. Now let's have a look at our API. Let's open it in browser. Yeah, as you can see, Visual Studio Code will set up the port forwarding as well, and the authentication as well if you run it through Visual Studio Code. And there you have it, our API. Now, you also need to secure your cloud environments. In order to ensure that your development security is aligned with your developer velocity, make sure you implement a centrally governed and secure engineering system. Also, you need to make sure that you allow only trusted, approved, and authorized DevOps pipelines and actors the ability to enforce supply chain controls. Lastly, you need to control deployment from non-trusted pipelines. Right, all of this will fortify your organization against threats such as build tampering and unauthorized access to package repository and production infrastructure. Now, DevOps pipelines are another important consideration when securing the development environment. To ensure your organization is producing verifiable and reproducible builds, you'll need to adjust security at every point, from compilers to build machines. Let's take a look at each step in more detail. For compilers, make sure that each compiler signs properly with validated signatures. For the build itself, make sure there are verifiable build manifests that describes sources, cryptographic hashes of binaries or artifacts, and full build parameters. With the built machines and infrastructure, you need to make sure that these are highly restricted with least privilege access applied and with ephemeral build agents. With DevOps services, you need to make sure that the build and release infra uses isolated mesh identities and sensitive tenant profiles are isolated. With compilers and user processes, you'll need to ensure that execution is done in isolation or in lockdown environments. For the software on built machines, make sure that all are signed properly with validated signatures. So practices like this ensure that your organization is secure from threats like compromised compilers and build machines and compromised dependencies. In order to harden DevOps infrastructure, you also need to harden access to code bases. The general rule of thumb is that everything should have a maintainer. You should follow least privilege access. Grant access to developers by organization. No global access. You should limit elevated privileges. Do so only when absolutely necessary and implement a finite duration on each access levels. Changes to identity controls like this help secure your organization against attack like source code exfiltration on developer machines and source code tampering or injection of malicious code. In order to ensure the code to cloud pipeline is secure, organizations need to do the following. Create Azure AD and device policies that will secure development machines. For example, if a device gets lost, wipe the device. Next, make sure all operations adhere to least privilege principles. Next, regularly scan for identity access management to ensure least privilege access management policies are adhered to. Also, use multi-factor authentication and dual key or just-in-time approval for privileged operations and human-induced pushes. Next, enable endpoint protection for all workstations and allow only registered devices. Lastly, inject identity early into the automation pipeline. Fortifying identity controls like this helps protect against attacks like compromised credentials and malicious insiders. Your organization should automatically detect and respond to suspicious activities. Here's a few things that your organization can do. First, ensure that you are monitoring for anomalous activities to identify and detect activities that are nefarious, from mass repo cloning to downloading or deletion. Make sure that you enable alerts and routing for security policies across DevOps pipelines. Make sure that there are regular scanning for IAM to ensure that least privilege access management policies are followed. Lastly, make sure that notifications of leaked secrets, tokens, or credentials to developers are automated. Enabling holistic monitoring can help protect your organizations from threats from within and escalations of brute force attack or intrusion access.
Hi everyone, my name is Shian. We understand that securing software has always been a challenge. Attackers, they are evolving their methods every day to gain access to your information, your customers' information. They want access to your personal assets and they can cripple your businesses. When a breach happens, it can cost millions of dollars to your business. So we want to shift security left to reduce risk and cost of fixing security breaches. To secure software development, we can look at a few aspects. Developers, they want to maximize developer velocity. They want to reduce complexity. Companies, they want to empower developers to contribute. CISOs, they want to augment security practices with latest cutting-edge forensic tools, detection tools to keep pace with evolving threats. They want to partner with development teams to gain holistic observability and to proactively hunt for vulnerabilities. They do not want to operate at a reactive state. Now let's explore embedding security into the developer workflow. We need to empower developers with integrated tools and automation capabilities. We want them to continue innovating and shipping new features without security slowing them down. How do we involve developers in security processes in a non-intrusive way? If you look at the development lifecycle, there are 4 stages: pre-commit, commit, deploy, operate, and monitor. We can start with threat modeling in the pre-commit stage to help you understand your threat landscape. Threat modeling includes defining security requirements. You can create an application diagram. You can identify threats, mitigate threats, and validate if the threats have been mitigated. You can download Microsoft's threat modeling tool to start assessing your environment. For the developers, there is a range of IDEs, security plugins, and pre-commit hooks to make sure that the code they are developing adheres to secure coding standards. It's also important to have regular peer reviews to align different teams about security risks and the code that have been recently introduced into the code base. In the commit stage, you can include static code analysis to automate code reviews and identify security risks. There is a code analysis tool within Visual Studio. There are also third-party tools such as Sonar Cloud and Zap that you can integrate into your continuous integration pipeline. As your developers develop application code, they can include security unit tests to automate security testing. It can involve running scanners or perform manual tests on running code. It's important to also manage your dependencies as developers increasingly use open source code, and you need to check for inherited vulnerabilities. Sometimes our developers would check in passwords, secrets, credentials accidentally, and the attackers can steal them to access your software systems. It will be important to include credential scanning into your continuous integration pipeline. Now, in the deployment stage, you can have infrastructure as code, which is a way to define your cloud environment infrastructure using code so that you can also scan for security issues in your infrastructure using tools. You can have dynamic security scanning to examine high-level security risks and check for your cloud configurations. You can have security acceptance tests to make sure everything is in line with the expectations and organization security goals. In the operate and monitor stage, you want to continuously monitor your security posture and set up alerts for anomalies. The alerts would notify your SecOps teams of potential attacks. Threat intelligence is a process of identifying and analyzing cyber threats. Microsoft Threat Intelligence is available. It collects global data, analyzes them, and provides insights to help you understand potential threats. You can hold regular postmortems so that your teams can take away lessons learned and to continue iterating as you move through the development lifecycle. To successfully implement DevSecOps, we can consider these 3 themes. We want to provide developer-first tooling to help developers become more cognizant of the security impacts of the code they have created. We want to provide native and built-in security capabilities to remove any friction for developers by including data and built-in automated security capabilities natively integrated in their workflow, such as IDEs. For automation, we want to automate checks within the developer's workflows. Instead of fixing a huge list of vulnerabilities just before production, developers can constantly be guided in the right direction through continuous security feedback that is automated. To secure dependencies, we want to understand the risks inherited through dependencies, external libraries, open source code that developers bring into the code base. We can consider 3 points. During development phase, we want to choose up-to-date and secure dependencies. In the commit stage, we want to examine the current vulnerability status of dependencies through dependency scanning. And after deployment, we want to continuously review the changing risks inherited from the dependencies. With these activities, we can prevent some of these attacks, such as injected malicious code. Malicious code could be injected to dependencies, and that could be inherited into your software. We can also prevent vulnerabilities accidentally created by the developers for the dependencies. You might have heard of SolarWinds. SolarWinds is a victim of sophisticated supply chain attacks. Software supply chain attacks target components that are trusted by their users to gain foothold within an organization or software. One form of software supply chain attack is dependency confusion. By using namespaces that are similar to the original, it can trick your developers in pulling down malicious dependencies that will be integrated into your code base. To prevent this kind of attacks, we make sure we are using trustworthy dependencies by using OpenSSF projects such as the scorecard. There is a GitHub action scorecard that helps you automatically generate security score for open source projects. The creator of the scorecard, the Open Source Security Foundation, is a cross-industry collaboration with members such as Microsoft and GitHub to improve security of open source software. Using an approved scorecard like this helps to auto-generate a report of security score for open source projects. It can define an initial evaluation criteria. It also helps to build a culture of security through improved visibility. Another aspect of securing developer workflow is to use static and dynamic analysis tools. With the static analysis tool, it can automate security review of your code. With dynamic analysis tools, it can automate simulated attacks on your running application within your DevOps pipeline. With this automation, you can prevent technical application security attacks that are common and included in these tools. A developer may hard-code passwords or secrets in their source code as they develop a feature and accidentally check in these passwords into the code repository. So it's important to check for hard-coded secrets to prevent certain types of attacks. Internal actors can access leaked credentials in private repos and gain privileged access, or the infrastructure can be compromised due to the leaked credentials in public repos. Automations can be applied. It can prevent secrets leaving developer machines with push protection, so as the developer updates code and merges it into the main branch, the scan is applied, and if a password or secret is found, that code will not be able to leave the developer machine. Automation can be applied to detect previously leaked secrets by scanning the full Git history in the code repository. Automation can be applied to resolve found credentials by revoking these credentials. Now that we understand how to embed security in the development environment and the developer workflow, how can we empower the developers with tools that can be integrated in their development workflow? For DevSecOps, there are two aspects. One is development and the other one is security operations. In development, we have a range of tools. We have Visual Studio Code, which is a popular IDE for developers. They can install GitHub Copilot to help them with their development, and they can also download plugins to help them deploy to Azure. We have GitHub Codespaces, which is a virtual development environment that developers can spin up in seconds. So whether they're working from office or from home, they can easily recreate that development environment easily. With GitHub, it is the largest development platform on earth with 83 million developers. They can easily script their CI/CD with GitHub Actions or even download ready-made templates from the marketplace. There is GitHub Advance Security, which also scans for your code, your secrets, to prevent any credential leaks, and it has the dependent bot, which can help you analyze your dependencies, create pull requests for your developers to review. We have Azure Container Registry to help you manage your containers and also to easily deploy the containers to Azure. For security operations, on the left we have Azure AD, the Identity Access Management tool. We have Application Configuration, which is a simple way to store your environment variables that can be reused across all your solutions in your organization. We have Azure Monitor, which is integrated to many of the Azure services, so you can understand the performance of your workload and to also diagnose any issues. There is Secure ARM Templates, a form of a template that you can use to script your infrastructure and also to scan for vulnerabilities. You can have Azure Policies, script your policies as code to help you govern the Azure environment. There is Azure Key Vault, where you can store your secrets, your passwords, your certificates securely. And with Microsoft Defender for Cloud, it is really essential for you to protect your Azure environment with the services that it provides. With Azure Advisor, it has a security score to help you understand your daily security posture. There is Azure Security Benchmark to help you understand where you stand in terms of security. There is the Web App Firewall, which helps protect your web applications against DDoS attacks. There is Azure Firewall, which is a cloud-native, scalable firewall as a service to help you manage against unauthorized access. There is also Microsoft Sentinel, which integrates advanced AI to help you analyze your logs for anomalies. Many of you are already familiar with Visual Studio Code. It runs on Mac OS, Linux, and Windows. It supports every programming language and has over 24,000 extensions that you can choose from, install, and help you develop faster. It has built-in support for Git, so you can version your code, push, pull from your code repository easily. It has Visual Studio Live Share, which is a way that you can pair program with another developer remotely. You can also prevent automatic code execution when a workspace is open in restricted mode. You can select folders that you trust by trusting a workspace. Remember the days where you had a wiki to document step-by-step instructions for your latest developer to onboard and recreate that same development environment? With GitHub Codespaces, that will go away. The developer can easily spin up their development environment in seconds, and also that environment can be compliant to your organization's needs. GitHub is an end-to-end developer platform. With GitHub, you are leveraging the best of open source for your organization in a secure way. With GitHub, you can easily integrate with Teams to enable ChatOps. With GitHub, you can integrate with Azure to enable GitOps, where your cluster configurations, your environment configurations can be configured in code. GitHub Advance Security is a developer-first, community-driven approach to overall security. With dependency scanning, you can scan your dependencies continuously, and it can also provide you automated fixes. With code scanning, you can scan your code for security issues. If you have custom rules, you can use CodeQL to script the checks for your code. With secret scanning, it can prevent credentials from being leaked from your code repository. Here I have my repository, which is generated from the Microsoft OpenHack DevOps artifacts template. Let's take a look at the security features. As a public repository, you have access to dependent bots and code scanning. So let's enable dependent bot alerts. It is a bot that would help you identify vulnerabilities in your dependencies. Okay, let's enable dependent bot alerts, dependent bot security update, and dependent bot version updates. So this would automatically open pull requests whenever your dependencies have an update. Dependent bot has found several security vulnerabilities in my dependencies. Let's take a look at the alerts. You would also receive the alert in your email. So let's take a look at this first problem. Okay, improper handling of exceptional conditions in Newtonsoft JSON. So this was a dependency that was embedded in this trip viewer C# project. Let's look at the security update. Dependent bot has created this pull request, helped me bump up the version of the dependency that would resolve this issue. And all I need to do is review and merge the pull request. And we're done. After resolving all the dependent bot alerts, let's look at setting up code scanning. There are two options. You can configure CodeQL alerts, or you can configure other scanning tools. Let's take a look at the available tools. So in GitHub, there are a lot of workflows that you can choose from. You can select a code scanner that works for you and your organization. So for this demo, we'll select the CodeQL analysis. This would generate the CodeQL.yaml. You can configure the settings and commit the changes. In this CodeQL.yaml, we can configure the language. So if you want to scan JavaScript, you can modify this. And this would configure the CodeQL to scan for JavaScript programming language code. and the rest are okay. So we're just gonna start commit, create a new branch for CodeQL and submit. This would generate the pull request, and you might want to update the description. No. This is change. This is ICD. How to test. And we're done. Let's create the pull request. And this would kick off the CodeQL analysis. Let's take a look at the job. Okay, the CodeQL scan has completed. Let's go back to the pull request, and it says that there are some results that are failing. Let's take a look at the alerts. Okay, these are found from the code by CodeQL. Now, some of these are alerts to indicate potential vulnerabilities in your code. So let's go ahead and fix all these issues. With the alerts fixed, the code scanning results is showing successful. So we can merge our pull request, confirm the merge. And to clean up, let's delete the branch. And we have fixed all the security issues. Lastly, let's look at the advanced security settings that we have configured in Code Security and Analysis tab. This is a public repository, so the dependency graph is already enabled, as well as the secret scanning. And if you want to see the dependencies in your repository, you can go to Insights, Dependency Graph, and here are the dependencies that Dependabot is monitoring. In summary, Microsoft is here for you. We have the technology to help you shift security left, unite DevOps and SecOps teams, accelerate secure innovation, and improve threat remediation time.